Okay, so obviously I'm biased, but I find it pretty incredible that everything that you already know about SQL is immediately relevant when working with Couchbase. Let's see how you put it to work. So to build a query with the .NET SDK, you're going to use the query request class, which is over in the Couchbase.NCL package. And it has obviously useful methods like add credentials for working with the rules-based access control in Couchbase, and the ability to add positional and named parameters within your query statement is demonstrated here. Pretty straightforward, but we're throwing in a type parameter to filter our documents by type within a query. Now, there's some other methods, obviously, to query a request that you'll want to know about. We'll familiarize you with a few here. For example, the ad hoc method takes a Boolean, and if it's false, the SDK and the server are going to attempt to optimize the query. There's a prepared statement capability with NCL, and it will try to do the prepared statement and take other optimizations. By default, it is true, and that means the query will be run ad hoc with no special optimizations, but you can ask the server to attempt to optimize. You can also execute specific query plans. In NCL, as you would learn elsewhere, there is a prepare statement that you can use to pre-prepare an encoded plan for a query, and you can pass that encoded plan along with your query request, again, if you want to customize your specific optimization for a specific query. There's also a scan consistency method that lets you control the consistency level of the returned results. Now, the default is not bounded. This favors speed on your query. It means that whatever data is currently indexed at the time the query is executed, that's what you're going to get back. Now, you can optionally set request plus to this parameter, and this favors consistency instead. It's going to require that all existing mutations at the time of the query are resolved completely before the result set is returned from this query. So it depends on your needs for a particular application, but the default is not bounded. By default, it favors speed. Now, again, as we've said throughout this course, to learn more about NCL, take our online course, Intro to the NCL Query Language for SQL People. That'll get you a good start on this language, and there's more beyond that. So once you prepare your query request, as you might expect at this point, the bucket is where you're going to send it. There is a query method. You pass your query to the bucket, and if you are generically typing this, it's going to come back with a result which is bound to your underlying model, as we've seen all along here. So a query result, as we've seen, returns with your success flag, and if there's an exception, you could throw that. Otherwise, you're going to get back rows of results. Now we call this a row, but that means a series of JSON documents, each of which are being mapped to their corresponding class within your model. Now, when you go to execute queries, we want you to know, even right here in a quick introduction to NCL, how you go about indexing them, because obviously you want speed. So all of this could be executed, as you'll see in the lab, through the query workbench in your server. So you can create a named index on a particular bucket for a specific attribute. This is the most straightforward type of index you could create. So for example, if I wanted to be able to look things up quickly by postal code in my Customer 360 bucket, I could specifically index all postal codes within those documents through this named index. Now, once you create an index, as you would expect, it's automatically maintained by Couchbase. If you need to get rid of an index at any point, you just drop it. Drop index bucket name.indexName is the syntax. And again, you could execute this query through the API, or you could execute it through the query workbench, or you could execute it through command line tools, and so on. Many ways that you could execute this query. Now, to use a secondary index, well, you just have to make sure you're executing a query that lines up with the index. So with NCL, I could, select star or select specific attributes from a bucket where a particular attribute has a value. And yes, there is an AND statement. You could have multiple filters here, as you'd expect from SQL. So I could, for example, select billing address objects from Customer 360 where they match a particular email. Now, by default, only the primary index is available, the one that you created at the beginning of this course, which is how you support full bucket scans for ad hoc queries like this. you will get a result back, but it'll take a while. I mean, we're saying here 4.89 seconds to get back all documents that match Dolores Riley, but that's entirely going to depend on your hardware and the documents in your bucket. So if you create a secondary index, such as here, index all email attributes within Customer 360, then that filter is going to get matched against this index because there's a index that directly matches the filter in the query that's lined up internally, and it'll pick up the index and your execution speed suddenly drops into milliseconds or less for that particular query. Now, what if you want to index less than all documents with a particular attribute value? Now, there's further you can go than just this, and we talk about it in the Nickel course and in the documentation. But you can filter your indexes. So I could create an index on a particular attribute, but only where some other attribute has a particular value. So here we're creating an index state status on the state values within billing address, but only if some other attribute of the document, status, is active. And that'll narrow the overall range. However, when you do this, you do need to line your queries up with the index. And so, for example, here, if I subsequently executed a query, querying just with a filter, a billing address state as Oregon, it's not going to pick up the index because the index is also expecting a where status filter. So unless I had a completely separate index just of state values, it's not going to get picked up here. However, if I built a query like this, where I both filter by the state and by the status, the index is going to get picked up and you get extremely fast response times. It does not, however, matter what order you put these in. So I could filter by status and then state, or by state then by status. It's just that you need to match all of the filters for the index that you've created. Now in the lab, we're going to walk you through executing this. We're going to walk you through creating the index for your queries and give you tools to play with and again continue learning this in your own way. Now when you get back, this is the end of the course. So let's take a quick review of everything we've looked at on getting data in and out of Couchbase. So you can insert new documents, insert key item pairs. You can read documents using the get operation of the bucket, and you pass that a specific key or a list of keys that you want returned. To update documents, that's the replace operation. You replace a particular item, a particular document at a specified key. But then we looked at the issue of having to keep separate track of inserts and replaces, and saw that we also have an upsert method that simply keeps putting data into the database regardless of whether it's there or not yet, which is great for high ingestion scenarios. And then of course we had to look at how to delete a document. You just remove a particular key. And then there's Nickel queries, which, as we've seen, puts the power of structured query language that you already know, or we assume most anybody looking at this course already knows, back in your hands for working with this JSON document-oriented database. Select, insert, update, delete, where, having, order by. You'll even find use keys statements that let you request specific keys or sets of keys, just as you might use a get operation. So it allows you to orient your entire development approach to Couchbase using the skills you already have. We hope you found this course valuable to get you started looking at how you can set a new direction in your project, team, and organization to work with the flexibility of a JSON document-oriented database. We hope you look at the other courses that we have available to learn the power that you've got with Couchbase. We hope you bring us along for the ride.